Good morning. Hey, we're going to start with Newton's method. It's a application of differentiation. It's another way that we use derivatives to find things out. One of the things we're going to try to find out today is how to find the roots of a function. We know how to find the roots of, say, a quadratic function using factoring, using the quadratic formula. If we get into cubics, it's a little more difficult. Newton, he's a very smart man, came up with a bunch of ways to do different things. One of the things he came up with was a way to find the roots of a function. And it uses the derivative to find the actual root of the function. So with Newton's method, we have to guess on an initial, where do we think the value is? And your calculator always asks you for that if you're using the calculator to do it. That's another story. So we're going to just guess here. It's this, and we probably would guess certainly much closer, but for the purposes of illustration, we're going to pick this one away. So we take our guess, we go down to the function. After that particular value of the function, we draw in the tangent line. Okay? The tangent line has a slope. The slope of the tangent line is the derivative, right? So if we look at it, I've got the derivative, which is the slope of the tangent line, is equal to the change in y, which in this case is the difference between the f of x sub 0 and 0. So right here is my change in y. Okay, f of x sub 0, x sub 1 minus 0, that's that. And then the change in x is x1 minus x2, that's my change in x, right there. So since we know x1 because we guessed it, we can figure out the f of x1 because we know the function. We can find the derivative of the function and plug in x1 at that particular value. So we would know everything in this except for x2. And what we would do is we'd find x2, and then we do the same process over. It's called iteration. We'd go up to the function, we'd draw in a new tangent line, we'd figure out where this value is, and then we'd, go down to the tangent line, draw a new one, and eventually we're going to keep doing this process over, and we're going to just kind of close in on the place where we want to be. So that's how this works. So let's solve this equation for x1. So what I'm going to do is multiply both sides by x1 minus x2. So this becomes x1 minus x2 times the f primed of x sub 1 equals the f of x sub 1. I don't need the 0, right? Now if I divide both sides by the f primed, I get the f of x sub 1 over the f primed of x sub 1. See, we want x2 by itself, so I subtract x1 from both sides, so I end up with x sub 2 equals negative x sub, sorry, it's negative x sub 2 equals negative x sub 1 plus the f of x sub 1 over the f primed of x sub 1. Almost there. I don't want to know what negative x sub 2 is. I want to know what positive x sub 2 is, so I just basically divide by negative 1, changing the signs of everything, so it becomes x sub 2 equals x sub 1 minus this ratio of the function to its derivative. Okay? Generally speaking, we'll write that in a general format, like so. Here. So if I want to get my next number, like if I want to get x2, I base it on x1. If I want to get x3, I base it on x2. So the next number is based on the one that I have now, and I just take the thing that I have now, subtract away the ratio of the function to the derivative at that particular value. Okay, this is subscript notation. Back when you were in 9th grade, we would have called this the next one equals the now one, and the reason for that partially is so that I don't blow your mind with all these subscript things. It's more understandable to use next to now, although probably at the time it wasn't. Okay, so let's just use this and figure out an answer to a question to try to find the root of y equals x cubed minus 4. We're going to give you an initial guess of x. My first x is 1, and I will give you an initial guess as you're working through these problems. Okay. So a couple things we need to know. We need to know what the derivative is. The derivative is 3x squared. Okay, you hopefully knew that. I'm sure you did, so I just went ahead and did it really quickly. And so we want to get x sub 2. And typically we'll just sort of make a little table as we go. X sub 2 is equal to x sub 1 minus the f of x sub 1 over the f prime of x sub 1. Okay? And so we just plug in what we know. We know that x sub 1 is 1 minus, well, let's see, the f of 1 is, let's see, 1 cubed is 1, 1 minus 4 is negative 3, and over, let's see, 3, and 1 squared is 1, 1%, so that's 3. Okay? So this becomes 1 plus 1, which is 2. So if I want to know now x sub 3 is equal to x sub 2 minus the f of x sub 2 over the f prime of x sub 2. And so I'm going to get, let's see if we think we can still do this with 2. We're going to get x sub 2, which is 2, right? Minus the f of x sub 2, so 2 cubed is 8, 8 minus 4 is 4. And then we're going to plug in 2 into there. 2 squared is 4, 4 times 3 is 12. So we get 2 minus 4, 12, so 2 minus a third, which is going to be 1 2/3, which I guess we'll go decimal-wise, 1.666, like so, and repeating with the little repeating mark, so we know that that's not exact, okay? All right, so then we go to x sub 4, and x sub 4 is equal to x sub 3 minus the f of x sub 3, and I know by right now you're going, well, when do we end? How do we know? We'll know when we know. We'll know we have an answer when we get there. So it's going to be 1.666 minus. Now, here's where a calculator is really handy. Let's see. I have the calculator loaded up down here. And what I did, pay no attention to that, is I put my function in y1, I put the derivative in y2. I set my table up. So I went to table set. And I set it so that my independent variable is on ask. So I have to type in what I want for an independent variable. It eliminates all this table start and changing table. I just punch in the x number that I want. It automatically gives me the y numbers. Okay. So when I go to the table, when I plug in, what's the number we want? We wanted 1.666, so 1.6666. Come on. It's delayed today. Okay, I hit enter, and it tells me that my function value is 0.624, and the other one is 8.32. So let's get back to there, see if I can remember. So 0.622408, I think it was, over, back to here, can't remember, 8.3267. 8.3267. And that's a 6. So I'm going to just grab my other calculator on the side here because I know you can all do arithmetic. 1.666 minus 0.62408 divided by 8.3267, and I get an answer 1.59. Okay, and so I use 1.59. Let's see, let's call it 1, I guess, okay? And so then we go to x sub 5, and x sub 5, that's 3 there. X sub 5 is equal to x sub 4 minus the f of x sub 4 all over the f prime, not all over, just that one's over f. And so I've got 1.591. I go back to my little calculator mode, I type in 1.591. I hit enter. I have my new values, 0.02727. So where we go here? Oh no. Minus 0.02727. I think that was the number. And the other number was 7.5938. Okay. 7.5938. I jump to the other calculator. 1.591 minus 0.02727 divided by 7.5. I think it was 938. I don't know if it makes too much difference at this particular moment. And I end up with 1.587. Okay? So here's the thing. Typically, we're going to be looking for our answers to be accurate to 2 decimal places out, okay, to the nearest hundredths. And if I go to the nearest hundredth on this one, I'm at 1.59. If I go to the nearest hundredth here, I'm at 1.59. And so at this point, I'm okay with that being the answer. If we need to go to the thousandth, we would run through another time. What we need to end up happening is we need to get the same answer with two tries in a row, okay, with rounding to the nearest hundredth. Once we get there, we know we have an answer, okay? So that's it, Newton's method to find the root of. So it's just a process. You just set up, if you just set up and you're pretty deliberate about setting your table up this way, it works out just fine. Okay, what do we got? That and then this. Those are the ones that we're going to work on in class tomorrow. Let's go back to here, or back to there, or back anywhere. And so if we have that process, it's not that difficult, involves the derivatives. It's a way to use the derivative to find the root of a function. Okay? Thanks for watching. If you learned something, if you have questions, you should ask. Ciao.